going through advanced calculus at university level, and we'll be investigating rates of change. So for this rates of change, we will be looking at this question, that is to design a space re-entry vehicle. And for this, right, we have to investigate the change in the temperature of a heat shield. So for this heat shield, right, we are designing for a heat shield that is about 1 inch thick for a re-entry space vehicle. And what we have to do is that we have to determine the temperature mu that is displayed over here at this graph. So we have to determine the temperature mu at each depth level x. So that x is represented by the x-axis. So we have 1 inch, thereby we divided the x-axis into 5 components at 0.2 inch, 0.4 inch, 0.6 inch, 0.8 inch, and finally at 1 inch. So what this graph basically portrays is the temperature change when at the different depth level of this particular material for a space re-entry vehicle. So the question here is, we need to determine the maximum change in the temperature per unit depth that the material can endure. So before we can find that, right, we have to find what is the average rate of change for the temperature when at different depth level. So if you look at this graph, right, what this mu represents is the temperature at a certain level of the material. So we have divided it into 7 segments. That is at 0.2 degree, 0.4 degree, 0.6 degree, 0.8, 1, 1.2, and 1.4 degree. So as you can see here, if you look at this graph, we see that at this point, point P, denoted by point P, this is the steepest point, Thereby, we will take this point as a point of reference for calculation for the rate of change. Then we have this starting point here as well. We'll be comparing this point together with this point. And in order to calculate the rate of change between this point and this point, what we have to do is, okay, so this equation is the average rate of change. So what we have to do is, we need to express it as the rate of change for mu, which is the temperature, divided by the rate of change of x, that is the depth within the material. So as denoted by this point, these 2 points, I already stated out what are the coordinates. That's why coordinates are very important. Alright, so the coordinates is, we are going to take y2 minus by y1. Alright, then after that we'll be dividing by x2 divided by x1. So how we re-express the entire equation for this rate of change investigation, that is, we take y2, that is 0.99, minus by y1, that is 0.5. Alright, so express it in this way. Then after that we get x2, that is 0.1, minus by x1, that is 0.5. So this equation over here, 0.99 minus 0.5 divided by 0.1 minus 0.5. And what this yield is approximately equals to minus 1.23 degree per inch. So this result yields the average rate of change of the temperature at the depth, at each depth. Alright. Then once we find out about this, right, we better understand what is the average rate of change. Then now we have to find out what is the rate of change at P. So this one gives us the instantaneous rate of change directly at this point. And it gives us more information about how heat is reacting at this particular point. So we look at this graph. What this graph represents is exactly the same graph, denoted by the same temperature range, denoted by the same x-axis, that is the depth of the material. But now we have to find out the instantaneous rate of change at that particular point P, that is the steepest point of this curve. And how we do it is, in order to identify P, first we find what is the tangent to the steepest point. And once we have found out the tangent, we use that to develop the secant of 2 points on the curve. So once you have developed the tangent and you use that to find the secant, it will yield point A and point B. So by using tangent, we find that point P is 0.5 and 0.5. Then using the secant method to secant across the curve, we get A equals to 0.32 and 0.32 and y equals to 1. Then for point B, we have x equals to 0.6, then y equals to 0. Okay, so from here, from this information, by using, that's why you have to learn tangent and secant and how to find, and using this to find the instantaneous rate of change. And by using this, right, you can re-express using the same formula, that is change in mu over change in x. So rate of change of temperature at point P, that is the point that you have found out using the tangent method. Now you express it as an equation. So you take this y2 is represented by 1 minus y1 is at point B, y1 is 0, so 1 minus 0 divided by, what is this? This is x, alright? So what is x? X2 is 0.32, then minus by what you have found out in point B, that is using the secant method, that is 0.68. So 1 minus 0 divided by 0.32 minus 0.68 is equals to minus 2.78 degree per inch. And this is very important because you need to analyze how the temperature changes within the material itself, so that you can design and choose a material that can withstand that kind of temperature, and you can find the material's figure and the statistics and how it reacts to temperature by referring to an established chart. And from there you can choose a material that is suitable for a space re-entry vehicle. And from there,
Tuition Near Me, your #1 portal for everything that is related to education. See you at Tuition Near Me.